So hello everyone, this is lecture 24 for the mathematical physics, in which we were studying about the differential equations and their solutions. So in the last lecture we covered the exact differential equation and we took one example. Now let's see one more example for the exact differential equation. Here it is, sin x cos hy. This is hyperbolic, okay, cos hyperbolic y dx minus cos x sin hyperbolic y dy equal to 0. So let me introduce you first with this term. Most of you know, but some maybe know. So this hyperbolic term can be written in the form of exponential like this. Just remember these things. Cos hyperbolic x will be equal to this, e to the power exponential x plus e to the power minus x divided by 2, and sin hyperbolic will be ex minus e minus x divided by 2. So that's how we write then. And differentiation of cos hyperbolic x is sin hyperbolic x, and for sin hyperbolic x it will be cos hyperbolic x. So remember these four formulas, they will be very important to solve any kind of question related to hyperbolic functions. Okay, now let's back to our main thing. This is m, this is n, so try to differentiate this with respect to y, this with respect to x. So you will get sin hy sin x. Here also cos x will give you minus sin x, so sin x sin hy. So they both are equal. Now they both are equal, then we call it is exact differential equation. Now we know how to find the solution. We can find either by m or either by n. So let's solve it with m. So u is nothing but integration of m dx plus ky. Okay, now substitute m from here to here and integrate with respect to x, then it will give you minus cos x here, and it will ky. Now n is nothing but del u by del y, so this is u, this whole term is u, so differentiation of this will give us minus cos x, this will give you sin hy plus dk over dy, and this is equal to n minus cos x sin hy. This will cancel out, this will be 0, and k came out to be some constant, okay, because this will be 0 only when k is constant. Now let's see. So k is constant, so we just substitute in place of k this constant. So u is nothing but minus cos x cos hy plus this constant. So this is also constant u, and this c is also constant. So cos x cos hy will give you constant. Okay, this will make a new constant again. Now there is initial condition given. At x equal to 0, y will be 3. So x equal to 0 will give you cos x equal to 1, and y will be 3. So c will be cos 3h. So the final equation, now you can find the value of c also, because cos 3h is nothing but e to the power 3 plus e minus 3 divided by 2 from this formula. Okay, and these formulas for normal cos x, you will get e to the power I theta plus e to the power minus I theta, and in this case of hyperbolic there will be no iota, just then other things are same. Okay, so this will give you this, and after solving this you will get 10.07. so you substitute in place of c this 10.07, you will get the answer. So this will be your solution of that differential equation. Now there are many equations which are not in exact form, but they can be reducible to the exact form. So how can we do that? Let's understand the procedure. So let's given equation is like in this form, m dx plus n dy equal to 0, but del m by del y is not equal to del n by del x, so we can't call it exact. Now we have to make it exact. So how can we do that? Let's write this m as p and n as q. So we get this kind of equation, pxy dx plus qxy dy, and del py del y is not equal to del q by del x. Okay, so let's write this differentiation as py, means differentiation of p with respect to y will written as py, and q with respect to y will written as qx. So this subscript represents the differentiation. So py is not equal to qx. Now to make it differentiable or to make it exact, we need to multiply a integrating factor to hold this equation. So multiply by integrating factor if, this is fxy, to the whole equation will make it exact. Okay, Means if you multiply with f in this equation, f p dx plus f q dy equal to 0, then this will be our exact differential equation. So what is this f? Now we need to find this value of f. So first, if it is now exact, then to find the value of f we are following these procedures. So if it is came out to be exact, then del fp by del y should be equal to del fq by del x. This was the condition, like in this case. Now using product rule, it will give you fyp plus fpy equal to fxq plus fqx. So you will get this equation. Now let's take one case. We call f as a function of x only. Okay, means let f is function of x only. Then what is fy? Fy will be 0 because f is not a function of y. And fx we call it f dash. Okay, and fy will be 0, so just substitute these values here. So fy is 0, so we will get fpy equal to f dash q plus fqx. Okay, now we can rearrange this equation as f dash q equal to fqx will came out this side, and f will be taken common. Then f dash q equal to fp, this is capital F, so f py minus qx. Now this f came out to be this side, means f dash is nothing but df by dx, and this f will be in this side and q in this side. So we'll get this equation. Now from here you can write this whole term as rx. If this is equal to rx, then take dx with this, rx dx equal to 1 upon f df, and 1 upon df is nothing but log f. So log f equal to rx dx. So from there f will be equal to e to the power r dx. So that's how we get this equation. Fx is nothing but e to the power r dx. So this will be the value of f, and if we multiply this f in this equation, so we'll get the exact differential equation. So this is one way to solve. Now we can go other way around, means now we can take f as a function of y only. Then we see that fx will be 0 and fy is nothing but f dash. So let's substitute them in this equation again. So we'll get the same solution like this, but now we will have fy, and that will be equal to e to the power ry dy. Okay, means now r is the function of y. So we'll get this equation fy as this. Now multiply with this in the same equation and you will get the exact differential equation. So to verify these things, let's take an example that if we still getting the exact form or not. From those derivations we get rx equal to this. We put this as equal to rx, and this was ry. So we can write them separately. Means rx equal to 1 upon q py minus qx equal to, it implies that fx is nothing but e to the rx dx. We find this. Okay, this was the integrating factor, and ry is nothing but, we can solve it either way, either with this or either with this. So 1 upon p qx minus py implies fy is nothing but e to the ry dy. Okay, now there is this example, minus y dx plus x dy. Now check if it is exact or not. So m is minus y, n is x. So del my del y will give you minus 1 and del n by del x will give you 1. So they are not equal, so we call it non-exact. So now you have p, you have q. So let's use this equation. So py will be, p is this, q is this. So py is nothing but minus 1 and qx is nothing but 1. So rx is nothing but 1 upon q py minus qx. So it will be minus 1, minus 1, minus 2, and q is x. So it will be minus 2 upon x. Now integrating factor fx is e to the power rx dx. So rx is this. Now we will get this. Now integration of this is nothing but minus 2 log x, and minus 2 will came inside. It will be log x is x to the power minus 2, and e to the power log x is nothing but equal to x. So e to the power log x to the power minus 2 will be 1 upon x to the power minus x to the minus 2, and it is nothing but 1 upon x square. This is x minus 2 equal. Okay, that's how you can write this. Just remember the property e to the power log x is always equal to x. Now we have the integrating factor f. Let's multiply this in this equation. So it will be minus y upon x square dx plus 1 upon x dy. Okay, after multiplying we will get this equation. Now you can check this equation. This is exact differential equation. Here del m by del y equal to del n by del x. Now you know how to solve the exact differential equation using u or means m or either n. So with the help of this m, let's solve this. U is nothing but m dx plus ky. So this is m, and integrate this, it will be y upon x ky. Now n is nothing but del u by del y. So differentiate this whole equation with respect to y. You will get 1 upon x plus dk over dy equal to n. N is nothing but 1 upon x. So this will cancel out. Dk by dy will be 0. So k will be constant. So just substitute here dk by 0. So we'll get, and u is constant. So this is constant. So y upon x is also a constant. So this will be our equation and of solution of the differential equation. Now let's take one more example. 2 sin y square dx xy cos y square dy equal to 0. This is p, this is q. If you try to solve that del py del y, that came not equal to, it will be not equal to del q by del x. Okay, so we need to make it exact. So how can we make? So we need to find the integrating factor. For that first we need this rx, and rx is nothing but 1 upon q py minus qx. So py is nothing but sine, this will give you cos y square, and y square will give you 2y. So it will be 4y this, minus differentiating this with respect to x will give you this. Now if you, it will be 3y cos y square, so it will be 3 by x. So you have the rx now. So integrating factor is e to the power rx dx. So this will be again 3 will came out log x, it will go inside, so x cube will be output. So this is our integrating factor. Multiply this within in this whole equation. Now this equation is exact. You can check. Okay, by del m by del y will be came up equal to del n by del x. So this is the exact differential equation. Now you know how to find the solution of this equation. It's just same. So u is nothing but m dx plus ky. So this will give you x4 by 4, and it will cancel out in ky. Now n is nothing but del u by del x. So it will be this means n is del u by del y. Okay, so you have this. So del u over del y will give you sin y will be cos y square, and y square will give you 2y, and it will be dk by dy. Okay, now you know n, just substitute from here, n equal to this. Now after cancelling out, you will see this will cancel out this. So dk by dy is again 0, and k is constant. So put here k is constant, so this will whole equal to constant. Now using the initial condition, what was the initial condition? At x equal to 2, you will get y root pi by 2. So substitute that pi by 2, this will give you sine will be 1, and x equal to 2, this will give you 16 by 2, c will be 8. So this will be your solution. Okay, let's take one more example. This 1 plus y square dx plus xy dy equal to 0. This is also not exact, so try to find the integrating factor using the same formula, py minus qs divided by q. So if you try to solve, you will get the integrating factor as x. So multiply with x in the whole equation, x square y dy equal to 0. Now u is nothing but m dx plus ky. Okay, so you have this m and m dx. So this is xy square. Now dx will give you x square by 2, and x square by 2 this plus ky. Now you know n is equal to del u by del y. So del u is this, So when you differentiate with respect to y, you will get here x square y only, and dk by dy. This will cancel out. Again, k is constant. This is constant. This is constant. So you will get this x square by 2 common. So it will be 1 plus y square. 2 will go inside that constant. So you will get this equation as your solution. So now I hope it is clear to you what are exact and how to make equations exact. So now let's see some linear differential equations. So what are linear differential equations? So I already told you, when there is no multiplication with y dy by dx, and you have the maximum power of this as 1, either it is second order, then maximum power should be 1. So that will be linear differential equations. Okay, and all these terms should have power 1. So this kind of equation you will call linear differential equation, and we will see the solution of same, where p and r are functions of x or constant. So p and r, either they will be function of x or constant. If rx came out to be 0, then we call it as linear homogeneous equation. Okay, means if it equal to 0, then you can solve it easily by just separable method. Means minus px, then y will be this side, and minus px dx. It will give you log y is equal to this, and just y is nothing but e to the power minus p dx plus c dash, and e c dash will give you this constant c. So this will be your solution, y equal to this, for the homogeneous, linear homogeneous equation. So this will be easy. But if rx is not equal to 0, then what? Then it will be linear non-homogeneous equation, dy by dx plus py equal to r. So now how to solve this equation? So let's put the same method. Multiply dx, take this r this side, py minus r, then multiply dx, and dx will be 0 this side. So you will get this kind of equation, dy plus py minus r dx equal to 0. Now you can see this is a kind of form of differential equation which we can turn into a exact differential equation. Then we can find the solution. So try to convert this into a exact differential equation, as we just discussed the whole method. So this is p, this is q. So py is p because it is py minus r, and qx is 0, and these both are not equal, so we need to make it exact. So rx is nothing but rx is equal to this py minus qx divided by q. So p minus 0 divided by 1, so it will give you p. P again. So rx is p, so if is nothing but e to the power r dx. So r is this px dx. So this is our integrating factor. Multiply this in this equation, and you will get the exact differential equation. So we just multiplied here, here, and here. Okay, now you can see the differentiation of this term y e to the power p dx will give you this whole term again. Using the product rule, try to solve this, you will get this, and in the right hand side we have this. Now integrate this whole equation with respect to x. Okay, means multiply with dx. So you will get this differentiation will get this will removed, so this will be y, and if we call it if, so y if equal to integration of this, so it will be r if dx, and there will be some constant due to integration, so this will be c. So this will be your solution for this kind of equations, linear differential equations. Okay, so this is y if equal to r if dx plus c. Remember this formula. Okay, if the equation is in the form of dx by dy, and it will be p by x equal to some, means it is in the form of that, means dx by dy plus p by x equal to ry, then it will just reverse all the terms, means x if equal to r if dy plus c. So that will be your solution. Okay, and if will be e to the power p by dy in that case, but mostly you will get this kind of case only. Okay, so try to solve them accordingly. So now we can use this formula to solve this kind of differential equations. So let's take one example. So this equation is given. Now you see that this is dy by dx minus, this is minus 1 is p, and it is r equal to e to the power 2x. So you can find the integrating factor e to the power p dx. So minus 1 dx, it will give you e minus x. So solution is y if equal to r into if dx plus c. So So this will give you ex plus c. Now multiply with ex both sides, so you will get y e to the power 2x plus c ex. So this will be your solution. Now let's see one more example. Y dash plus 10x plus y equal to sine 2x, and this initial condition is given. So here p is this, r is this, if will be e to the power p dx. So 10x dx is nothing but log sec x, and log e to the power log x will give you this. So log sec x will be equal to sec x. So just multiply this, means not multiply, use the formula y if equal to r if dx plus c. Now this is 2 sin x cos x, 1 upon cos x, so you will get 2 sin x here, and now integration will give you minus cos x in this side. So this is 1 upon cos x will go this side, will give you minus 2 cos square x plus c cos x. This will be your solution. Okay, now there is one more question, try to solve this. In the next lecture I will give you the solution. So y dash plus 2y e to the power exponential x, 3 sin 2x plus 2 cos 2x. So try to solve this. So let's end lecture here. Thank you everyone.